Hey guys, it's Miss Stilts here, telling you about the distributive property of multiplication. We've worked with the associative property, commutative property, and the identity properties of multiplication and addition, and now we're going to add in the distributive property. So we've looked actually at this distributive property already this year in math. When we've done our mental math and our math talks, we've used decomposition to help us rearrange the numbers to use them more easily mentally. So this is actually the distributive property. So when we multiply mentally 26 times 3, we've used decomposition to take apart the 26 into its two parts, the 20 and the 6. So then what we need to do is to multiply both the 20 by the 3 and the 6 by the 3, adding those products back together. So when we do 20 times 3, we get 60 because 2 times 3 is 6. Bring your 0 down. We're adding to that 6 times 3, which is 18, to get our final product of 78. This is also called a break apart strategy, and that might be a little easier to understand because we're breaking apart the 26 into two parts, the 20 and the 6. Here's another example of the break apart strategy. We've got 5 times 27. 27 is a two-digit number, so let's break that apart by place value. We have a 20 and a 7. Now we can see that we can multiply each part by 5. 5 times 20 is 100. 5 times 7 is 35. And that's an easier set of numbers to add. 100 plus 35 is 135, so 5 times 27 is 135. So let's use a break apart strategy to multiply mentally. We're going to do 56 times 2. So think first, what number are you breaking apart? Well, of course, it only makes sense to break apart that 56. What are its two parts? It's got a 50 and a 6. So if we just say that number, we find the parts, 50 and 6. Now I need to multiply each of those parts by 2 and then add them back together. So 50 times 2 is 100. That's an easier problem to do mentally. 6 times 2 is 12. That should be a known fact. And those are two easy numbers to add. 100 plus 12 is 112. Now, we can also use the distributive property to join factors together. So look at this expression here. We have 8 times 3, this means multiply here, plus 8 times 5. So 8 times 3 means we have 3 groups of 8. 8 times 5 means we have 5 groups of 8. Well, how many groups of 8 do we have altogether? I have 3 groups. I have 5 groups. Oh, I have 8 groups of 8. So I wonder then if 8 times 3 plus 8 times 5 is the same as 8 times 8. Let's have a look. Let's see, 8 times 3 is 24, 8 times 5 is 40, and 24 plus 40 is 64. And 8 times 8 is 64. It's the same thing, but by adding those numbers together first, I do a little less work mentally. This is called the join together strategy. We can also do this when we're subtracting in between here. So we have 8 times 32 minus 8 times 2. Well, 8 times 32, that might be a little difficult to do. But what if I go ahead and subtract out this 2 here? So I have 32 minus 2. Then I can do 8 times 30. Well, I know 8 times 3 is 24, so I bring that 0 down and plop the 0 on. So 8 times 32 minus 8 times 2 is 240. I just made it a little easier. Let's try another one. With a join together strategy, let's evaluate 5 times 8 plus 5 times 2. So what two numbers do you want to join together? The 8 and the 2 here, because they're both being multiplied by that same number, that 5. So what's the new expression or problem that we're asked to answer? 5 times 10, because when I join together the 8 and the 2, and I've got addition in the middle here, well, that's 10. I want 10 groups of 5. Well, I know 10 times 5 is 50, so now I can do that problem mentally. Here are some problems for you to do. You don't actually have to find the final answer, but figure out what numbers would go in these blanks. Write these down in your journal or on a piece of paper and bring them with you to class tomorrow so that we can discuss them in our teams. Thanks.